In this video, we're going to be taking a look at a charged particle that's moving through a magnetic field, and we're going to solve for the magnetic force. And then in addition to that, we're going to also include the force of gravity to find a final net force. So we have a charged particle down here that's moving upwards through this magnetic field. The magnetic field is in blue, that is going into the screen. So we are going to use the formula F equals QV cross B. And then you may need a sine of theta. In this case, you actually won't, and we'll see why in a little bit. So we're going to go ahead and solve for our value, and we're going to also use the right-hand rule as well to see what direction the object is going to be pushed. So we have a charge of 55 microcoulombs. That is positive. So we have a positive charge, which is similar to what the case normally is. So we would use our right hand. If it was a negative charge, then we would reverse that final answer or use our left hand. So if we're using the right hand rule, we would stick our fingertips straight out and stick our thumb straight up from there to make a 90-degree angle with our pointer finger and our thumb. And our fingertips would be pointing into the screen. Our thumb would be pointing up with the direction of this velocity. And then our palm would then be facing to the left. So it's going to receive a force being applied to the left. Now with that in mind, we will use that a little bit later because that vector is going to be pretty significant. And we're going to go ahead and plug in our values here and then solve for our magnetic force. So I went ahead and I took my charge, which is 55 microcoulombs times our 16,000 meters per second, times the value of our magnetic field that it's moving through, 0.125 Teslas. And then I use the sine of 90 degrees because the object is moving at a 90-degree angle from the magnetic field. So the magnetic field is going straight into the screen, and then our velocity is going straight up. So sine of 90 is going to equal 1, so we're not too concerned about that. Now, if you were just doing a regular QVB problem, you'd be done, and that would be your magnetic force. But in addition, we are also going to include the force of gravity. So we have a mass over here. So what we're going to do is we're going to use our forces and connect them tip to tail as we do with vectors. So we'd have this force over here of 0.011 newtons. And then in addition, we would have a force of gravity coming down, and that's going to be mg. So that's going to be 0.011 times 9.8. So just coincidentally, our force over here did end up equaling our mass, but that's not very common at all. So if we multiply these two numbers here, we're going to get a force of gravity of 0.1078 newtons. Now, what you do is when you combine those vectors tip to tail, we have a resultant vector, and that resultant vector is going to be our net force. So if we go ahead and use the Pythagorean theorem will give us the hypotenuse of our triangle, and then we can go ahead and get our net force. All right, so we found our net force, which is the final thing we're looking for. In addition, we can go ahead and find an angle, which we'll call theta. So for this angle, we're going to go ahead and use the inverse tangent function. So the inverse of tangent, and we're going to go opposite. The opposite end is our 0.1078 divided by our adjacent side that's in red, our 0.011. And then that's going to give us an angle of 84.18 degrees. Okay, so that would mean the object is going to receive a net force that is applied 84.18 degrees, and that looks like it's below the horizontal if you want to add that in addition to it. But I hope that was helpful in helping you analyze a charged particle moving through a magnetic field, solving for the magnetic force in red, solving for the force of gravity in green, and then combining those two for a final net force in purple, and then in addition, finding this angle in orange. Thank you very much for watching and listening.